Alright, we're going to complete section 5.2, polar coordinates and graphing and equations. We have three more different types of curves left to discuss. The first one is a rose curve, and a rose curve is characterized by equations of the form r equals, oops, there's a typo there, a cosine n theta and r equals a sine of n theta. These have graphs that are rose-shaped and flower-shaped anyway. As long as n is not equal to 0 and it's even, the rose will have two n petals. If n is equal to positive or minus negative 1 is odd, then the rose has n petals. And we're going to do an example over here with r equals 3 cosine 2 theta. And we're going to create a t-chart just like we did on some of the other problems that we've worked with. In fact, most of them. And our t-chart is going to have graphs, graphing values, because this is cosine, between 0 and pi. So we're going to start out with a theta equaling to 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. And of course our equation is r equals 3 cosine of 2 theta. So when we put in 0, we have 3 times the cosine of 0. And the cosine of 0 is, of course, 1, so this number is just 3. When we take a look at the cosine of pi, well, it's actually 2 times pi over 6. That is to say, it's 3 pi over 6. I'm sorry, 2 pi over 6, which is pi over 3. So if we want the cosine of pi over 3, the cosine of pi over 3 is actually 1/2. So this is 1/2 times the 3, so this is 1.5 or 3/2. The next one I have is 3 cosine, and it's pi thirds times 2. Alright, and so this is actually the same thing as 2 pi over 3, and at 2 pi over 3, this is a cosine value that's actually negative 1/2. So we have negative 1/2 times 3, so this is negative 1.5. And I'm noticing from my notes that I actually want to just do 1/4 of this, and it's because of the repeating rose shapes, the flower shapes, so I'm going to actually go back here. We're going to move our pi halves down, and I'm also going to move the pi thirds down, and we're going to insert in here a pi over 4 that I had not included up until now. Okay, I think I've fixed that enough. This is pi halves, sorry, pi thirds, and I want to go back and look at pi fourths. If we do pi fourths, this is 3 times the cosine. This is the cosine of 2 times pi fourths. Now, pi fourths is, times 2 is pi halves, and the cosine of pi halves is 0, so this is actually 0. And then we'll do pi over 2, the other one that I had before. And it turns out we've got some really nice symmetries here, so we don't actually need to go all the way over to a whole pi value, which isn't common. If you did, it wouldn't hurt anything. Alright, so this is 3 times the cosine of 2 times pi halves. So 2 times pi halves is pi, and at pi the cosine value is negative 1, so this is negative 3. So we're going to take a moment and we're going to plot these particular points on an xy curve. And we'll chat a little bit about what's going on with the graph. So I'm going to graph 0 radians and 3. So we've talked to before that that's actually putting a 3 right here. Next we're going to do pi over 6, and I'm going to draw in those lines that we were using last time. Alright, so this is pi over 6, and we're out 1.5. And then we're at pi fourths. Oops, I didn't get in there. There we go. So at pi fourths, we're at 0, which would be back at the pole here at the beginning. At pi thirds, I'm at negative 1.5, which would be down here somewhere, more or less there. And then at pi halves, I will actually be at negative 3. Alright, so I didn't get these marked yet. Let's go ahead and drop them in here. 2, 3. 1, 2, 3. This is supposed to be at negative 3. So this is what we have. Now what you see is a portion of the graph, and if we continued on we would see more of it, and I will leave that as an exercise to you that this really does in fact happen to give me more. But the rest of the graph will go like this. And so we get a flower called a rose. This is a rose with n petal, or with 4 petals, because I had 2 times n, so I have 4 petals. All right, a lemniscate is the next one. A lemniscate sort of has the same feel to it a little bit as a graph with a rose, but it doesn't actually have the whole rose. It actually has what looks like propellers, like on an airplane. So these equations are r squared equals a squared sine 2 theta and r squared equals a squared cosine 2 theta. One we're going to take a look at is r squared equals 9 cosine 2 theta. So a few things to identify first is that this is r squared equals, and we could write this as 3 squared cosine of 2 theta. So the idea being that we can actually have that, you know what, let me set up a t-chart. I think that'll probably make it easier for discussing this virtually. All right, so we have our angle measurements. We have 0, pi 6, pi fourths, pi, alright, so the first one, I'm sorry about that, this is just such a mess, is pi over 6. Then we had pi over 4, and then I had pi over 3, and then I have the same similar ones, or rather, and it's negative, so negative pi over 2, 6. Okay, negative pi over 6, negative pi over 3. And actually, let's do 4 first. And negative pi over 4. Okay, so we're going to use this inside of this cosine equation now. Alright, so this is 9 cosine of 2. So this is actually 1. This ends up being a 9. This is theta, and this is r squared. Alright, this is 9 times. Alright, so the cosine of pi thirds, we did that a little bit ago, that's actually 1/2. So this is 4.5. Pi over 4 is actually going to multiply out to 9. Pi over 4 multiplies to pi over 2. The cosine of pi over 2 is 0. Pi thirds is 9 times cosine. This is double the angle. Actually, let me pull that out of there. This is pi over 3, and this is going to go into 2 pi over 3, and the x value at 2 pi over 3 is actually negative square root 3 over 2. And then negative pi 6 is actually you give me that same 9. And then you had over 6's. So the cosine curve that has negative pi 6 doubles, so negative pi thirds. If I were thinking about some of the other ones, I have negative pi thirds, or pi thirds rather. Okay, so this one we're on now is actually going to be an angle of, well, the cosine of negative pi thirds, and negative pi thirds down in quadrant 4. And the cosine value would actually be of 1/2, and it's positive 1/2 on this particular one, so 4.5. And then this last one actually says negative pi over 4, so if you double that, it becomes negative pi over 2, and this is undefined for what we're working with. So we want to plot the r and the theta, so r right here, let's draw this in. So here's r based on what you've been working on. We have plus or minus the 3. We have plus or minus 2.1. We have 0. And then at pi over 6, pi over 3, we have, let's see, let me get that approximation. Okay, so for this one, an approximation would be about 7.8. We have 4.5 on the next one, and this one is undefined. So we're going to sketch a graph with these features. It's not going to be real big because I'm running out of space on these slides, but we'll put it right here in the right-hand corner. Oh, in fact, we might be able to give it just a little bit more space. Okay, so we're going to plot our XY pairs. You go out to 8. Alright, so we have one point to plot at 0 on the radius and 3, so that's going to be right here. We've got 1 to plot at pi over 6 and 2.1, so we're looking about right there. We are going to plot pi over 4 and 0, which would be here. We have pi thirds and 7.1. Okay, I found this typo over here. This is actually negative 1/2. So this is negative 1. Okay, so this is actually negative 1/2. So this is actually negative 4.5. Alright, so pi thirds and negative 4.5. So let's just get this pi thirds in, since I think that seemed to help us a lot about when we were working on these. So here's pi thirds. And you know you have to be anywhere along that line, and you're actually at pi thirds. We need it to be a radius of negative 4.5. So it's down here, something like this. And then negative pi 6 means going pi 6 in the, I don't say wrong, but opposite at least direction. And so we have our negative pi, or this is positive pi 6. They put in negative pi 6. Okay, there's more or less the same teacher. And we're out at 4.5. Okay. I think we did miss one when we were doing it earlier. Because the screen kind of went all funky on me. If I just do it again. Okay, this is pi thirds down here. And for pi thirds, we have 9 times the cosine. Let's make it negative 2 pi over 3. And that would also give me that would actually be a negative x value of negative 1/2. So this is negative 4.5. So at pi over 4, we end up plotting a point. We don't end up plotting a point, but at negative pi thirds, we plot a point at negative 4.5. So this picture actually ends up looking like, oh, I do see I've got one error. Let me double check on that one. Okay, so it just looks like I've plotted a point in the wrong spot. I think I was supposed to be at negative pi sixth, and then it's supposed to be at 4.5, which would have actually not given me that one. What else one was there? Let's see, it wasn't negative pi sixth, because I got that one. Okay, one of the things that I did make an error on is down here, actually. This is not undefined, I'm sorry. I guess I'm really a little bit too tired to be doing this right now, but I want to get it finished up for you all. So this is 9. This has negative pi fourths, and if I double it, I've got negative pi over 2. And negative pi over 2 gives me a cosine value of 0, so I do actually get a 0 back at there instead. Alright, so I don't have quite all my details in the right spot. I'm missing and making some errors. The overall image that I want you to walk away with this is that I end up with a shape that looks something like a propeller. It looks like this when I've graphed it properly with the right values in there. And that's called a propeller shape, or actually the technical term for it is a lemniscate. The last one is a shape that looks something like this, and this graph actually has a shape of a spiral. And to do this graph, if we plotted a few XY ordered pairs, we would see very quickly that our angle measurements spin out of control. So let's just plot a few of these particular points. We'll do theta, and then r equals 3 theta. That is 3 to the theta. So I'm doing negative 3 pi over 3. And we're just going to use our calculator to get these approximations. This is nearly 0. It's actually about 0.01. I have negative pi, and this one comes in at about 0.03. I have negative pi over 2, so we're doing kind of quadrantal angles, and that's 0.2. I have 0, and that has a coordinate of 1. I have pi over 2, and that has a coordinate of 5.6. And we'll do one more. I have pi, and it has a coordinate of 31. Which is actually too large for me to plot, but you have the idea anyway. You will have the idea anyway. All right, so we're going to plot these ordered pairs in a polar plane, which means I need to go out to, well, in theory it says 31. I know I can't do that, but I can go out to the value above it, which is 5. So if I plot these, and as I move my way around, actually starting out at very, very barely above the y-axis, or x-axis on the y-axis right here. I'm going to negative pi at 0.3, which is just a little bit further out. I'm at negative pi over 2, which is 0.2, again, for a little bit further out. The next one I'm at is actually 0.1, which is right here. I'm at pi over 2, which is halfway through my first quadrant, 5.6. So it's actually pretty far out there. And then we have pi 31, which of course we can't graph. But the image that we get if we were able to graph these is that of a spiral. did wrong. I was supposed to be plotting pi halves 5.6, which would be up here. That's better. Now we'll be able to construct what I need to. So, and if we could plot more, we would see more readily how quickly this actually blows up.